What's up guys, and welcome to this video. This is on question 9 of Photons and Electrons of the 2017 supplementary exam. So yeah, let's get into it. So basically it says, in experiments to demonstrate the photoelectric effect, a beam of light with a single frequency is shone onto a clean metal surface. The maximum kinetic energy of the electrons was measured. The experiment was repeated at different frequencies of light, and the graph of maximum kinetic energy versus frequency for potassium metal was obtained. Okay, so we're used to these graphs, basically an EK versus frequency graph. Okay, and first of all we have a definition. So it says define the threshold frequency. Okay, so the threshold frequency is the minimum frequency of incident radiation at which electrons will be emitted from a particular metal. Okay, so that's just a definition and we get 2 marks. Okay, we also know right here, okay, so we know that is our threshold frequency as well. Okay, cool stuff. Then it says, use the graph to help you determine the minimum energy needed to eject an electron from the surface of potassium. Okay, so 9.2, we're looking for the minimum energy, so we're going to say energy is equal to Planck's constant times F from our formula sheet, which is equals to, so the Planck's constant is 6,6 times 10 to the minus 34, and F, okay, we're going to read that off our graph, so that is actually, we can go with F naught even if we wanted to, and that would be 4,4. Okay, so we have times 4,4, remember times 10 to the 14 because of that right there, and the answer that we get is E is equal to 2,9 times 10 to the minus 19 units of joules, and that's the answer. Okay, question 9.3. Okay, so question 9.3 says, use the graph to describe the relationship between maximum kinetic energy and the frequency of the incident light. Okay, so basically we can say that if the frequency, so if the frequency is less than F naught, okay, then, okay, so if it's less than F naught, so here's F naught, so less than F naught is in this section right here. Okay, if that's the case, then EK max is 0. Okay, and basically no electrons are emitted or ejected. Okay, so that's the one scenario because that is our threshold frequency F naught. But in the other case, if the frequency is greater than F naught, then we can say that then EK max increases as the frequency increases. Okay, so does that make sense? So basically we're saying that if we're on the right hand side of F naught, as the frequency increases, we're also getting increase in EK, which is true. Okay, so that yeah, there we go, and that we get 3 marks for that. Okay, so the next question says the work function of copper is double the work function of potassium. Okay, so what do we know? Then it says 9.4 says the experiment is repeated with copper instead of potassium, which is one. Okay, so basically we have to pick which one best represents the 2 graphs, where the straight is copper and the dotted line is potassium. Okay, so how are we going to pick? Okay, first of all, we know that these slopes must be the same. Okay, so for 9.4, let's say check slopes equal. Okay, and the reason for that is we know that the slope is equal to our Planck's constant h, right? So if the slopes or by equal I mean parallel. So okay, so the slopes must be parallel. If the slopes aren't parallel, then they are not options. So I would say A and B are parallel. So C and D are not options. Okay, and then secondly, we've been given that the work function of copper is double the work function of potassium. Okay, so what we're looking for is that we know that the threshold frequency is double as F naught is double, so the threshold frequency for potassium must increase, or it must move to the right because it's been doubled. So basically what we're looking at is the threshold frequency here has gotten less for copper, so the answer for 9.4 is B, because we're looking for the work function of copper. So copper is the solid line, so this is copper and this is potassium. Okay, so basically copper has got a higher work function, and so it's got double the work function, and so it has double the threshold frequency. So the threshold frequency moved from here to here. Okay, so we have B as our option. Okay, and then the last question, question 9.5, says light of a frequency of 15 times 10 to the 14 hertz is incident on the copper metal. Okay, so this time on the copper metal, calculate the kinetic energy of the electrons ejected from copper. Okay, from copper. So we know we're working with copper and not potassium. Okay, so how we're going to work, or what equation, the governing equation we can work with is going to be HF. So energy, let's say HF is equal to the work function plus the EK max, or the maximum kinetic energy. Okay, so we know H is Planck's constant, which is 6.6 times 10 to the minus 34 times F, which is that frequency right there, the incident frequency, 15 times 10 to the 14, okay, is equal to the work function. Okay, so we know what the work function, we calculated the work function for potassium, so the work function for copper is twice, so 2 times this answer right here, that answer right there, so 2 times 2,9 times 10 to the minus 19 plus the kinetic energy EK max. Okay, so the only unknown here is EK max, so we can solve for EK max, and the maximum kinetic energy is equal to 4,1 times 10 to the minus 19, and the units of energy is joules. So that is our final answer. Okay, cool stuff, and that's the end of the question. Okay guys, that's also the end of the paper. So I hope you guys found these tutorials useful. Yeah, thanks for watching.